day everyone. For this video, I will discuss my project on digital communication, which is frequency shift keying, or also known as FSK. FSK is the digital modulation technique in which the frequency of the carrier signal varies according to the digital signal changes. A frequency shift keying is a frequency modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier wave. The output of FSK modulated wave is high in frequency for a binary high input, while low in frequency for a binary low input. My FSK circuit is mainly composed of 4 parts. These are high frequency oscillator, low frequency oscillator, square wave generator, and the FSK modulator itself. I used Wien bridge oscillator for both my sine wave generator. I only changed the capacitor value and the resistor value for the Wien bridge. Using the formula 1/2 pi RC, I was able to calculate my required frequency for the 2 oscillator. For my high frequency oscillator, the value is 44 kHz, while the other one is approximately 10 kHz. For square wave generator, the frequency is approximately 500 Hz. It will serve as the message signal of the FSK circuit. The output of this generator is simply the binary ones and zeros. A typical block diagram of an FSK transmitter is shown in figure. It comprises of 2 oscillators, which is sine wave generator, and input binary message, which is square wave generator. The reason behind this, FSK modulated signals are represented in terms of 2 different frequencies. The frequencies are called mark frequency and space frequency. For mark frequency, it has represented logic 1, while space frequency, it has represented the logic 0. There is only one difference between these 2 carrier signals, which is the carrier input 1 having more frequency than the carrier input 2. The transmitter circuit is built around CD4066B quad bilateral switch, a digital pulse generator, high frequency oscillator, low frequency oscillator, and 7404 hex inverter. The high frequency and low frequency oscillator is made up of Wien bridge oscillator. The value for high frequency is 44 kHz, while for low frequency is 9 kHz. A high frequency sinusoidal signal from oscillator 1 is applied at pins 1 and 8 of IC1, which is controlled by binary data from the binary message at pins 13 and 6 of IC1. A low frequency signal from oscillator 2 is applied at pins 4 and 11 of IC1, which is controlled by binary inverted data applied at pins 5 and 12 of IC1. That's all for the whole part of my FSK circuit documentation. Now, I will watch for you the simulation of my whole FSK circuit using the NI multisim.